Hello and welcome. We've got another paper 2 worked example, and this one is all about a small remote controlled model aircraft that has 2 propellers. But we only really need to think about one of the propellers. Our job, as you can read up there, is to show that in a time interval of 3 seconds, the mass of air propelled downwards by one propeller is 0.55 kilograms. You guessed it. Let's jump over to the chalkboard. All right, so I've diagrammed the one relevant propeller here. We've got the density of the air, and we're trying to show that there's a mass of air that's going to be propelled downwards in 3 seconds is 0.55 kilograms. Make it a fresh piece of Hagoromo chalk for this calculation. That way I can't go wrong. Density equals mass per volume. Because we're given the density, that's a nice clue about how we might attack this question to show that the mass is a certain value. So right away, we'll say that mass is equal to the density times the volume. If you read carefully through that question, it said that you're allowed to assume that this is a cylinder here with a diameter of 16 centimeters. As I've kind of drawn here, let me make that a bit more clear. So we've got sort of a cylindrical sort of shape. In general, the volume of an object is equal to the area of its base times its height or its thickness or its depth or whatever you sort of want to call that third dimension. It's like length times width is an area times height, the familiar sort of formula for volume. The area of the base of a cylinder is the area of a circle. And so the volume of a cylinder, you may know, is pi r squared, the area of a circle, times the height. We can easily calculate the radius of the circular cross-section of our cylinder, right? If the diameter is 16 centimeters, then the radius r here is, everybody ready for this? I don't know if you guys are ready. 0.08 meters. See what I did there? I went from 16 centimeters to the radius 0.08 meters. Why meters? Because my density is in per cubic meters of volume. So if you can take care of that centimeters right away, you're comfortable enough sort of doing that. You might also know that centi means 10 to the negative 2, and half of this is 8, so say 8 times 10 to the negative 2, or 0.08 meters, that's the radius. How are we going to get the height here? We're going to have to calculate the height from the velocity of the air, and that's why they gave us the time interval here, 3 seconds. So we can calculate the height of our cylinder. It's like a distance, right? Distance equals rate times time. So velocity times time is going to give us the distance, right? In this case, a height. You could just think about that as sort of, well, this is a velocity, right? 7.6, and so it's meters per second. So if I multiply it by the seconds of time, I'll cancel out seconds and I'll be in meters. So you can easily show that the height of our cylinder is 7.6 meters per second times 3 seconds, or what's that, 22.8 meters? Double check that in the calculator, right? 21.8. All right, so we can make all those substitutions here. So we've got pi, we've got a radius of 0.08 meters squared, we've got a height of 22.8 meters. There's lots of, chances to make mistakes here, like not converting centi, but the units will sort of take care of that. Like you'll find your mistake once you get to this if you're always mindful of sort of substituting units. I think a lot of students will get stumped on this part right here. Like, how do I go about solving for the height just given a velocity? And again, sort of trusting the units is very helpful. Like, why did they give me a time in seconds? A velocity in meters per second, right? So we can do something there. All right, so working through this, you get the volume. I know that you know, you students have a noble goal to one day maybe be as cool as me, you know, keeping a calculator in your shirt pocket like this. I'm just like, it's a noble goal. Keep dreaming. So we've got pi. I'll edit out the after later. Times 22.8. All right, so we get 0.45. 0.4584. You know, and there's more. Meters cubed. That's the key, right? So meters squared times meters is meters cubed. So now I've got the volume. I've already kind of outlined my path to the solution here, right? The mass is going to be the density times the volume, right? This bit here is just to calculate my height of my cylinder. All right, so the given density. Let's put that bit of working right over here. Right? We've got the density right here, 1.2. Right? So we said mass is density times volume. I always like to write out volume because V for velocity, V for voltage. You don't want it to be confusing. You know, somebody's like, it's already confusing enough. All right, so the mass is equal to 1.2 kilograms per cubic meter times 0.4584 meters cubed. So the meters cubed are going to cancel. That's sort of where you would find your mistake if you left, you know, this in centimeters or something like that. You know, you wouldn't have cubic meters of volume. You would be able to cancel out this. 1 times this is this, but 1.2 times this seems like it would be 0.55. And so let's already have this 0.4584212 in my calculator. Times 1.2 kilograms per cubic meter. It gives me a mass of that, right? 0.5501. Now this is paper 2. And so we know well in paper 2 that that's part A. There's going to be part B, C, D, E, F, G. So what else do we want to do with this? Calculate the increase in momentum of the mass of air in A, the downward force exerted on this mass of air by the propeller. And if you want to know the answers to those, you're going to have to tune in next time.